Okay, so today we are starting 1.2, which is measuring and constructing segments. And then you guys should have already glued down your ruler postulate. If you haven't, you can take a second and do it now. Right, so the first thing we're talking about today is the ruler postulate. And I have a feeling you guys already know the first part, that we're using a ruler to measure the distance between 2 points. But then part of the ruler postulate is that a point is going to correspond to one and only one number on the ruler. And that is called a coordinate. So the ruler postulate tells us on a number line, just like on a ruler, every point can be paired with a number and every number can be paired with a point. Just like you can see here, right? Every point with the centimeter is labeled. The same thing happens on a number line. Also, fun fact, if you have MPerks or if your parents have MPerks, there's a coupon in there. I don't know if it still is. I used it yesterday where you could get a free ruler. So if your parents go grocery shopping today, maybe see if they have one. And this one's cool because it clips right in your binder. And then I'll be using straight edges a lot. And then it'll just help make your notes look very, very nice. So something else that we're going to talk about today is the distance between two coordinates. So that is the absolute value of their difference. And whenever difference, that means it's going to correspond to what type of problem? Subtraction. Okay, so you're going to end up subtracting. The distance between two coordinates, for example, A and B, is just denoted by AB. So that's why it's important that you guys are using your correct notations, because see how this doesn't have anything above it? If there's nothing above it, it means the distance. And then if you had like a segment or a line, you'd have to label that. So to find the distance, you're just going to subtract the 2 points. This just means it doesn't matter what order you subtract them in, because we're going to be taking the absolute value. And a lot of times people remember that the absolute value means you're always going to have what kind of answer? Positive. But can anybody tell me why? What is the absolute value measuring? Yeah, Joe. Good. Okay, so it's the distance from 0. That's why it's going to be a positive number. It's measuring the distance. So we're going to do A together. And then I'm going to give you a minute to do B and C. So for part A, I'm trying to find the distance between F and E. And I'm going to do that using the absolute value. So if I look at F, Tyler, where on my number line is F? -1. So that corresponds with -1. And then Cameron, what about E? Where's E? -4. So you can set this up one of two ways. I'm just going to show you both ways. Okay, so the first way, I could just take -1 because that's where F is, and then minus -4 because -4 is where E is. Remember, when you're subtracting a negative, it's like you're doing what? Adding a positive. Okay, so -1 plus 4 is going to be 3. The absolute value of 3 is 3. Now I'm going to show you that it doesn't matter the order that you do that in. Because even if I do -1 minus, if I do -1 minus -4, or if I do -4 minus -1, I'm going to get the same result. So -4 plus 1 would be -3, which is going to give me 3. Okay, so using that example, I want you to go ahead and do B and C. I also just want to remind you that your notebooks are graded, so it is really important that you follow directions. When you come in, you got to come in, get started, make sure that you're writing everything down, and then if you miss something, then you got to go back and watch the video. Okay? Okay, so if you look at your number line, where is C? So C's at 2. D is in between 4 and 5. Yep, so that's going to be 4.5. So once you find those 2 points, Caden, what do you do with them? So once you have C and D, right, is 2 and 4.5, what do you do with them? You find the difference, which means you just have to do what with them? You're going to do what if you're finding the difference? You're just going to subtract them, right? Okay, so, and then after you subtract them, you have to find the absolute value. Okay, so if you subtract 4.5 and 2, it doesn't matter the order that you subtract them because you're going to be finding the absolute value. Okay, so for the next one, x and z, x is between 1 and 2, so that's going to be what? Nope. Nope. So it's a number between 1 and 2. So 3 would be bigger than 2, so not between them. Yeah, so 1.5, right? Okay, and then z is, well, that's what you're probably saying is 3. Yeah, z is the negative 3. Okay, so I have 1.5. And I have 3. And what am I going to do with them? Subtract. And then once I subtract, what do? Absolute value. Okay, now, when you subtract those, you are subtracting a negative. Okay, so 1.5 minus negative 3 is going to end up being a positive, which is going to be 4.5. Is there another way that I could check to make sure that those are correct on my number line? Yeah, you know? Yeah, can I just count the spaces and make sure they're correct? So if xz means the distance between them, can I just start at x and then look, right? Are we looking up here? So this would be a half, and this is 1, 2, 3, 4 spaces. So that's going to be 4.5. Okay, so can you do it like that? Yeah, that's fine. Yep. If you have C and D, 1, 2.5, 2.5. So you can also just count your space in between. Okay? When would probably doing it like this be more beneficial than counting? Yes, if you have very, very large numbers, right? If you were trying to find the distance between 200 and negative 117, it'd probably be quicker to just subtract them than to move your finger on the spaces. Okay, so now we're going to turn this over to our next page, and I'm going to give you the next foldable. So most of you are going to be able to fit this on one page, but I want you to just double check. So the only writing besides the foldable that I'm going to give you is right here. So depending on how big your notebook is, like if you wanted to put that on the back page, that would be fine. Everybody in my earlier hour was able to put it on one page. You just want to put that towards the top. So this is on a new page, okay, so not on the back. Anytime we have a foldable, I won't put it on the back. Okay, it'll be a new page. And then when I'm passing that out, I want you to write about congruent segments. And congruent segments are going to be segments that are equal. Have you guys heard the word congruent before? So congruent is used instead of equal when we're talking about objects instead of numerical values. So like if we have two line segments, we'll say that the segments are congruent. If we had two numbers, we'd say that the numbers are equal. As soon as you get those, whoever I gave them to in your group, please pass those back so your other group members have them. And then if you have extras, just hold it up, please. You guys are gonna have extras. Okay, so if you have an extra one, just hold that up and I'll come get it from you. Now, we have a special symbol for congruent, and that special symbol is going to have an equal sign. And then it has a squiggle above it. Remember when you would write about or approximately, you'd have two squiggles? This has one and then an equal sign. Okay? And then what you would say is that your two segments are congruent. I haven't given you any instructions to fold or cut, so you should still be here with me. So when you're writing that these two are congruent, notice how I made sure I kept my segment notation in there. So this means AM is congruent to MB. When you see it in a diagram, your diagram is going to have these tick marks. So this is going to show you AM is congruent to MB. Does anybody know what we call M if it splits a segment in two? What do you call a point that splits something in two? You guys remember from Algebra 1? Well, it's written on the handout I just gave you. That is something that splits it in two, but it's not a point. It is the midpoint. Okay, so with your foldable, all we have to do with this one is we are just going to fold that directly in half. And then you do not have to glue that in yet. If you want to, you can. It's just some people find it easier to write when it's not already glued in. Okay, so what we're going to do is first we're going to do our definitions. If you want to cut on the dotted lines, you can. I would just wait until we're done with all of them. So what we're going to do today is we are going to do the definitions, and then we are going to do some of the examples together, and then some of the examples are going to be part of your homework. So the very first flap we have is really important. That's called the segment addition postulate. And we're going to do a lot of things that have to deal with segment addition. And if you even think of what the title is, segment addition, what you're doing is adding segments together. So in this postulate, we know that if B is in between A and C, if we add the segment AB to BC, that's going to give us the length of that whole segment AC. So the gist of the segment addition postulate is if you have AB plus BC, that's going to equal AC. If you look for that postulate in your textbook, it's called 1-2-2. The numbers really are not important. I think the names are more important than what number it is. Okay, so the segment addition postulate says if we add this segment plus this segment, we get the whole big segment. So that's what I tried to show you in orange. So if we take AB and we take BC and we add them together, that would equal the length of AC. Now, in the next two definitions, we're going to have different parts being split up. And for this one, a segment bisector is going to be either a line or a ray or a segment that cuts another segment into two equal parts. And then some things to notice on the drawing. Again, we have those two tick marks, and that shows you just from the drawing that those are going to be congruent. And drawing the line XY, that is your bisector. Okay, so bisector, when you're thinking of that word, right, the bisector cuts something into two sections. And those two congruent sections in this case are line segments. So your segment AY is congruent to the segment BY. And then I highlighted this in our definition because it is going to split it up into two equal parts. And you'll see that that's true in our last definition as well. Right, so the midpoint of a segment, that is a point on a line segment that divides it into two equal segments. And we think of that as the halfway point, and we call C the midpoint. So for that drawing, we have AC that's congruent to BC. And then once you're done with that, go ahead and read through your examples. And for each example, we are going to draw a picture. So you can go ahead and you can read the description, and then you'll be able to draw the picture from the description. Okay, so once you're writing that down, go ahead and start at your first example, and you can draw your picture, and then you can draw your picture for all of them. Just make sure you do leave room for your work. Okay, so for the first example, it says if C is between D and E. So if C is between D and E. So think about how that's going to look. So if something's between D and E, I would start off by drawing a segment that has D and E on it. And it says C is between, but we don't know how far in between it is. So really, as long as it's in between them, it doesn't matter where that point is. I put mine a little bit closer to D. You could put yours a little bit closer to E. You could put it towards the middle. But we don't know if it is exactly in the middle. Now, they tell you that DC is equal to 1/2 of, bless you, 4x plus 6. Okay, but you can simplify that. What can you do with the 1/2? Okay, and when you multiply them, do you guys remember what property that is? Distribute, right? You can distribute the 1/2 to the 4x and to the 6. So if I'm distributing, 1/2 times 4x is 2x, 1/2 times 6, 3. So when I'm labeling that on my drawing, which is DC, I'm just going to write 2x plus 3. And then I also so for mine, I just put that right above it. Right? So I knew where the 2x plus 3 was coming from. The CE is going to be 3x plus 1. And then DE is 44. Okay, so your picture should look somewhat similar to that. Now, whenever they tell us that we have to find something, that's something that I highlight so I know exactly what I'm trying to find. So what we're going to do here is we're going to use our segment addition postulate. So if I'm using my segment addition postulate, I know that 2x plus 3 added to 3x plus 1 is going to equal that full length, which is 44. Okay, so this segment, DC plus CE equals the full segment, DE. And then once you're here, it just becomes an algebra problem where you want to combine like terms, and then you're going to solve for x. So when I combine like terms, I usually just underline my like terms. So 2x and 3x is 5x. 3 and 1 is 4. And then you should be showing your work. There are some steps like the subtracting 4, where if you are more advanced, if you just went 5x equals 40, that would be fine. But I know earlier in the year, I saw some of us were struggling with equations. And so it's going to be really important that you're writing out every step. Now I found x, but that's not what the directions are asking me to do. They're asking me to find DC. So remember that DC is equal to 2x plus 3. But don't I know what x is now? Yeah, it's 8. So 2 times 8 plus 3 is 16 plus 3, which means DC is 19. And then I can do something similar for CE. CE is 3x plus 1. Well, I know that x is 8, so I'm going to substitute that back in to find CE. Okay, so part of your homework is going to be to do example 2. And so we are going to jump down to example 3. Again, that's something that you can draw your picture for. It says EF bisects AD at C. So if you look to the left, okay, which is right here, we just drew something that was a bisector. Okay, so now we're going to do something similar. I'm actually just going to show you this. Okay, so if EF bisects AD, I'm just going to draw AD. And EF is bisecting it. And those are both segments. And it bisects at C. Now we talked about earlier that if it's a bisector, it splits it into 2 equal parts. So if I know that AC is 5x minus 8 and CD is 16 minus 3x, because it splits them into 2 equal parts, I know that AC and CD are congruent. Okay, so what you need to do is set that equal and then solve. Okay, your homework is on Google Classroom, which is going to be problems from the book, and then you're going to finish your examples. Okay, and then I will post a reminder in Google Classroom.